Hello and welcome to the Insights Overflow podcast, the show where we talk to customers, partners, and industry leaders about the lessons that they've learned in order to make an impact. Today I'm joined by Hugo Pienaar, who's a Digital Services Director at Adroit Technologies. Hugo, how's it going?
Hi Andrew, thank you. Well, thank you very much for having me.
Good, so I want to learn sort of a little bit more about the world of SCADA and sort of Adroit and the history of Adroit, and then I want to sort of touch on the future in terms of how all of this is moving to the cloud. So I know when we first met, I heard the word Android before, and now I'm hearing Adroit. So maybe you can give me like a quick history of Adroit Technologies with the origins of the name and sort of what you guys do.
So we're not Android, we are indeed Adroit. Yes. It's often misconceived these days. Adroit Technologies is a local company, however we trade worldwide. We focus on factory automation, specifically in SCADA. So we're a software development house that developed our own software over the past sort of 30 years odd end. And then of course we provide solutions on top of that software, specifically for factory automation. Mitsubishi Factory Automation has a minority share in our business as well, which then of course enables us to be the sub-Saharan distributor for their factory automation hardware, which typically now includes PLCs, VSDs, robots. You can imagine anything that automates a plant, so to speak. And then of course, as a combination, we then offer those solutions into any sort of factory, any automation process, any industry that makes use of machines to control and monitor their processes.
Yeah, I think it's one of those industries like, say, in this modern world, we take, for instance, that this cup is manufactured. We take, for instance, a car is manufactured. So behind the scenes, there's like the silent hero that's sort of automating all of this stuff. And it's something that we don't really see. And in this sort of hyped world of software, and enterprise software and industrial software, it's sort of the ugly stepchild in the software game. Whereas a lot of the stuff that you're doing is driving critical infrastructure that if that stuff goes down, stuff doesn't work, right?
Very much so, very much so. So I always say that I'm fortunate to be working in this sort of space, because we're also exposed to fascinating technologies and processes. As you said, often if you just look around yourself, anything that materially you see is manufactured somehow in a process. And Adroit typically would be involved in every single one of those manufacturing processes. Rightly also, we often do critical infrastructure, which also means not just the process is critical from a production environment, cost environment. If we, for instance, refer to a mining operation, if they have a breakdown or downtime, it costs millions in revenue. And so also if we look at critical or even sensitive sort of productions in the medicine industry, for instance, high quality is required, so the processes need to flow a very specific design pattern, and of course also ensure that process is followed right through. So it's critical, and then of course critical infrastructure. When we can't monitor, when we can't switch on the necessary infrastructure, you may not have power, you may not have water, and that is critical to monitor, of course.
Yeah, like I heard this concept a couple of weeks ago. It's called vibe coding. So basically what it is, you sit back and you let ChatGPT code for you, and you just sort of vibe out and you sort of give it your ideas. Now you sort of contrast that with the fact that, if you're running software in critical industries, the stuff, you can't have bugs, or you can't have those moments where like, oops, I didn't think of that. So the software and hardware combination has to be ultra reliable. So I think, going back sort of the history of, 30 years, you've really refined the reliability of that, of the software. And I think one thing that people maybe don't understand is how important the hardware-software relationship is. Because you've got the PLCs that are controlling sort of the physical world, but that needs to be orchestrated by the software.
Very, very much so. It's critically important in that whole process, right? So maybe just to give a little bit of an explanation on exactly what SCADA and the process is, looking at factory automation, as you alluded to there, is the first part is, of course, your field devices, or your controllers in the factory that typically monitors and or controls that specific piece of equipment. That is essential for that machine to operate. That's the first part. The second part to that is then first get visibility. So our SCADA software is exactly that. It provides insights, visibility to that machine in almost a digital twin. These days it's a common term in a digital twin world. That's effectively what SCADA is. The second part to that is then to potentially control that process via the SCADA through those controlled interfaces, which is critical. Of course, 30 years ago, that was all that was required. It was if you had a digital representation, you could manage your system. On the invent of development of information technologies and data and information as we know it today, of course, that's a second tier layer that then were developed over time now, where today we don't just need to control, we want to analyze post-processes. We need to capture that data. We need to understand where we can improve the process. And we can also need to now integrate into all sorts of other new information technology systems, ERP systems, that all now ties together. When the past it was very much silo operations, but you had to have that critical communication and process handling. It is, of course, key to ensuring stability.
And that's a tough one, because how do you take 30 years of history, sort of fast-moving technology, sort of adapting customers, innovative customers, and still provide that reliability, and then do all these innovative things like push data to the cloud, do machine learning, the AI, the hardcore analytics. So how did you guys sort of first decide that you needed to go on that journey, let's call it, to cloud, and then maybe just sort of describe your sort of journey in the process to sort of get to where you guys are now?
It is quite an interesting journey in a way. It's not something, I think the whole digital transformation process and theme has been around for the last 10 years, I guess, and even prior to that. But I really think it's the sort of came to the market of the IoT sort of space and technologies that sort of fast-tracked the need and perhaps the opportunity to integrate on-premise the traditional type of SCADA and machine control and potentially move that into the cloud space. So that was really, I think, the catalyst for everybody in the industry to start to look at what cloud can offer for the industrial space. So the industrial space is a bit unique to others in that sense, because we spoke about the critical nature of the infrastructure and the process. So it was very much an isolated network always. So you sit, we refer to it as on-premise, systems, and SCADA will always remain on there. Of course, now today with the development of cloud and all these sort of technologies, it sort of motivated more strongly the need for that domain to now start to extend into the IT domain. So we often talk about this IT-OT conversions and the need for those two domains to sort of join. So that is really the motivator behind it. Of course, cloud offers all sorts of opportunities. If we look at data science technologies, machine learning, just visibility. So access to data, as we all know today, we want data in front of us on our mobile, right there and there. Okay? So we need information access. We look at the historical type of on-premise isolation. It was a challenge. So cloud provides us access to data, and it provides us access to all these new sort of technologies, which we want to leverage.
Yes, I think I've seen a couple of people make the mistake, particularly in the IoT space. They're taking a consumer-orientated IoT approach and try basically jerry-rig it into the industrial space. And within the industrial space, the SCADA, it's always been the data point. So trying to put new sensors within the production environment, they were there already. And, trying to do that consumer approach to the industrial space, it just never quite worked. Because also in the industrial space, you need credibility in that space. People need to trust you as the gold standard within that environment. And, they're going to be less open to changing their process because it has been working. So that's where I think Adroit has got a real advantage in bringing those industrial customers into the cloud space, more so than a third-party IoT provider trying to infiltrate the industrial space. Is that sort of the same thing that you see, or how do you see it?
Absolutely. I think, again, if you sort of track back 10 years with the inventor of the IoT sort of space, I think everybody were excited and jumped on the bandwagon, we included. We all had a different sort of view on the opportunities that it was going to present, but I don't think it really played out to that extent. Okay. However, I am optimistic and glad for that cycle of development, because it did introduce us to different approaches on how systems can exchange data. And I do think that it presented new types of technology and interfaces. So in our space, typically, I often say, SCADA has been the digital world for the last 40, 50 years. Okay?
Yes.
So it's IoT was no new concept for us. Okay. It is a sensor. Okay? It's just a very lightweight sensor, and it uses a bit of a different protocol to move data into the endpoint. And typically this is via the cloud or different sort of infrastructure. So it didn't really shook the world of SCADA, okay, but it presented potentially new market opportunities, however, which may not necessarily fit the big enterprise SCADA sort of environment. If you think retail sort of spaces, they never really managed the SCADA system. But now with IoT, it presented that sort of opportunity. So that still exists today in the opportunity side of things. But the IoT brought us to the understanding exactly as you said. It's not a one fit size for everything. I think there's very much to focus point. The initial focus point was all about getting that IoT device into some sort of platform to create visibility to it. So I think there was a bit of a misunderstanding and overexcitement in the world to understand that sort of technology already existed. So I think the realization was quickly that what do we present once we do that? Now what? What is really the value and the benefit that you're going to get if that's all that we do? And I think that's potentially our strong point. We understand enterprise data or industry data for that. We understand the value that you need to derive, and of course that's the partnership that we together with OQLIS also look towards. So we take part in that, in ingress of that data, and we look towards OQLIS then to extend that value proposition, because we understand data, we understand industrial data. And I think that's the big thing that the platforms always struggled with. They don't necessarily understand the type of data.
Yeah, so I think that sort of brings us to an interesting segue in that, our paths crossed some years ago. And, it's come to the point now where, you recognize OQLIS has particular strengths in terms of what it can do and how it does things, and sort of Adroit has particular strengths on how it does things. So maybe what we can do is just describe, let's call it from an architecture point of view, sort of how things are happening, and what our two different platforms, what they do within the market.
I'll step back to maybe how our paths crossed first, to just explain perhaps the partnership and the opportunities that we foresaw in partnering with OQLIS. I think we often, as a development house, we're guilty to want to do everything ourselves, wanting to build every software and platform out there. But looking at the sort of IoT space and the lessons learned, what we just described, we identified that there are many platforms out there, and technologies is something in that space that is ever changing. So it's a risk exposure that to try and go and compete with existing specialist systems like OQLIS, to try and catch up and then play in a market that's not our core strengths was a risk that we've sort of identified. So from the get-go, we sort of approached this opportunity to look for a partner that specializes in cloud management of data, presenting and providing that sort of analytic tools, and then the later technologies like the machine learning and the AI model. And that's sort of what we found with OQLIS, which were a big draw factor for us. It's a complete solution, and it's a specialist solution. So we, on top of that, from a strategic point of view, we knew what we wanted to deliver to our customers and to our clients. We want to drive value add. As we've alluded to, we understand our data. We've already collected our data. So we sit with a vast amount of data on many thousands of installation bases. That's not our challenge. So it isn't the typical IoT challenge. Okay, we already sit with that data. So for us, it was about how do we enable a platform like OQLIS through our client base and our technology, and how do we then leverage the whole value chain to then go to market and deliver value to the customer, with speed and accuracy. And that was sort of our strategy, and we saw a good fit between those two technologies to achieve that. So the first step for us was to develop our Adroit Edge Gateway, which was basically the middle layer to transfer and ingress that data that we've collected, that we control and manage, and provide it into the OQLIS or cloud, as a wider application, but in this sense directly into OQLIS. And then we, on top of that, the value driver that we present is, again, we understand the processes. Because we're in control of that process, we can almost contextualize and build very specific data models or data sets that we can then present in the OQLIS platform. And of course, then it's easy to drive dashboards and analytics through that.
I think you make an interesting point, particularly on the word context, because what I've seen in the past is it's not just about connecting a sensor; it's about where that sensor exists in the ecosystem, and having the context of that data point, all its attributes and the metadata that surrounds it. That becomes important for reporting. And when you really want to slice and dice it across different hierarchies, you need the context and the attributes of that. Yeah. And that's stuff it's all contained in
absolutely critical. I think personally that is one of the big shortfalls of, again, the IoT platforms and space, dare I say, is exactly that. The focus was too much on the technology driving, but foregone the sort of context and the structure. So while you can always build it after the fact, the problem is that becomes a secondary function. Where do you manage it? How do you manage it? How do you continuously manage it?
And what's the source of truth?
Exactly that. So with our system, we obviously have a sort of unified context model, or UNS, that provides that context right from an object or a piece of equipment, piece of machinery or process. So we've already mapped that. And that sort of context we push right through. So you have a single set of truth, and you always know to refer back to that data point.
Yeah, I think that let's say make it specific. So like there's a customer in the water utilities that has Adroit, that basically you've connected that to the cloud and to OQLIS, and basically what you're trying to do is how do you optimize filling a reservoir, so that there's water for everybody to use. So basically it's going from sensor in the reservoir, basically through the cloud, pushing, and then, within a couple of seconds, milliseconds, basically it appears on the dashboard. And then ultimately then, you want to produce forecasts, you want to do machine learning, and then ultimately drive a smart business decision, like should we start refilling, yes or no? Is that sort of an accurate way to
100%. It's one of the projects currently that we're busy with in the utility space, the larger part of South Africa actually, where there's various components of managing, obviously, the distribution. This is specifically to potable water, which is your drinking water that you typically get out your tap. So depending on the type of distribution network, there are various stages within that distribution line, whether they use reservoirs to manage the flow and pressure, or whether it's just simply a storage unit. Within that process, there are different areas or sections within that. Of course, being critical infrastructure, and right now we understand and know that there's huge pressure on all these distribution infrastructures, whether it is aging infrastructure that tends to produce leaks, So it is, being a critical resource as well, it is of course very important for us all to consume or to conserve that sort of resource. So we are envisioning a product or a solution within our technologies with OQLIS that we look at the various processes within that distribution line. Now, typically on a reservoir, we would monitor through the SCADA, we would monitor the level of the reservoir and the different flows, the in and out flows. And we've produced a specific process function, if you would, that then monitors and converts and automatically balances that process, and it tracks that sort of data. That is now sort of our first sort of modular approach, So then we can deploy that modular process throughout the distribution line, and through that we can then start to do all sorts of analytics and advanced analytics with machine learning. So one of the approaches is typically a reservoir has a cycle, as we understand. There's demand cycles when we all use and consume more water in the morning, and then perhaps later at the evening again in a typical cycle, daily cycles. So there's a typical curve within a reservoir when it will be refilled and when it drains a bit, when the demand is in excess. And of course, then to refill it, there's a supply side of things. And then there's a demand change as well. Now, a demand change could be a natural change, just with more consumers that gets onto that specific area, or it's a burst pipe. So how do we detect automatically, firstly, is there a change in pattern? Okay. And secondly, can we detect and identify the potential cause of that? Okay? So from a high level sort of bird's eye view, we want to use machine learning to then look at the patterns, identify the patterns, understand when we move away from the expected sort of pattern, from a refill or a demand cycle, and that we can then feed that back as almost a prescriptive intervention to say, we've detected, we are not going to recover to the level that we should be to have the necessary resources supplied to meet the next sort of cycle on demand. So what actions they need to be taken, is in the hands of the utility then to perhaps add another pump cycle or add another bypass or however that they action that. The second part to that is, of course, also to be able to just simply determine whether a specific area or unit is just simply over demand, where we can also use machine learning, seasonalities, and a few other sort of weather patterns and that sort of thing, that we can understand the impact on exactly that sort of demand cycles.
Yeah, I mean, if you just, think about what you just described, like there's a lot of steps that go into that. And so I'm just thinking about like all the technologies that have to work in order to produce that output. It does make sense that in these particular scenarios, the journey to the cloud is the right decision. Then you can use, high compute that's maybe not sitting on premise to do some of the machine learning training, some of the inference. You can use the big data storage in the cloud and, not have it stored. So definitely, to solve these kinds of, let's call it advanced problems, that sort of cloud journey, it's like, it's the only option in a lot of ways if you want to solve for that last piece of the stretch, and on premise as it exists now is, how do you ask your customer, okay, cool, in order to solve this, buy this massive server with a lot of GPUs or something like that. It's not really going to make sense.
No, it's not. It extends again also to what I believe is probably the most important part, is accessibility to the information, the data as well. The traditional setup just does not does not provide access to all the role players, So I think what's also happened in the last 5-10 years, since really access to information has really become, hands-on with the phones and all that sort of thing, is we expect to have that information, So traditional SCADAs and systems, information analysis was post-process, always, What happened? Something broke. Now let's go and understand what happened, okay? In today's life, that's not good enough, We need to be in front of the 8 ball to prevent that sort of catastrophe or breakdown to happen. The same goes with the use case that I've just described, So we got to get in front of that process to understand potentially what's going to happen so that we react faster. But we also need to share that information with more role players, and not bottleneck it through a specific process. So to me, absolutely, you need a platform to produce that type of information, and it just makes sense to have that on the cloud. That's just natural. It also makes sense for a lot of our processes and systems to get that sort of data moved out of the secure environment. I didn't touch on it earlier, but it's quite important. Okay. Security and access is still very much a high-risk environment. Critical infrastructure, they just doesn't expose that type of networks to potential threats. So it makes a lot of sense to take that information, move it outside of that infrastructure and environment, and it provides a safe place to share that information.
Okay, so almost like separate the concerns so that you actually leave what's on premise more secure instead of opening up more, say, attack vectors.
Exactly.
Okay, I see. That makes sense.
Exactly. Yeah. So that is definitely a byproduct of moving data to the cloud, extending, of course, the power and also the availability of value-added services. I think that's also, to me, an exciting prospect. Once you have the data in that sort of sphere, it is easy to extend it into specialist services. When we talk about water, just as a use case example again, there are certain specialists that, for instance, will do pump efficiency, or a leak detection, or a hydrologist that will look at the planning. For them, they need access to data. So they've got the know-how, but they need an easy way to get, or an accessible way to get to that information without needing to go through the traditional sort of barriers. So I think that opens up the barrier to that, to share of that information, which adds more value to the overall solution.
So I think one of the last concepts I want to talk about is, so Adroit, you've grown through a partner network and sort of relying on sort of implementation partners and sort of a greater partner network. We've partnered in terms of what we're going to do. So in your mind, like, what do you think makes a good partnership? And, what separates good partnerships versus bad partnerships? Like in your mind, what would you say that you've seen work? What are the characteristics?
Yeah, it's a good question though. I think there's a lot of lessons learned over the years. Not specifically partners being at fault, just you've got to find that synergy first of all. In a partnership, there's got to be, both needs to be contributors. I've often seen that great technologies come together, but they sort of wait for each other. Who's doing what? Who's going to take the lead?
Yes.
Everybody wants to benefit.
Yes.
So I think for me, a good partnership, and what we identified between Adroit and OQLIS is there's specialist areas that each focuses on. We share the same sort of values, and we share the same approach to business. I think that's also key. So for me, understanding the boundaries, how each partner is going to contribute to the larger value chain is absolutely key. I think the extent to know what you want to achieve in the long run is also very important, to align those sort of strategies, long-term strategies. And then, of course, technology. Technology has to align. And I think those are the key factors.
No, I couldn't agree more. So Hugo, thanks so much for spending time with me today. I really appreciate it. You've been watching the Insights Overflow podcast with Hugo Pienaar from Adroit Technologies. We'll catch you on the next one.